Hello and welcome. In this video, we're going to really focus on proofs involving some of the angle work we have already been doing. Our objectives in this lesson are that I know and can apply the linear pair postulate and vertical angles theorem, and that I can define and apply the right angle congruence theorem. So don't be overwhelmed. There's a lot of proofs in this lesson, but we're really going to focus on how to think through them. Let's go ahead and jump in. We are going to introduce 5 new theorems or postulates into our bank of things that we can use in proofs today. Most of them are pretty intuitive, but I want to make sure that we talk about each one as we go. So the first is the right angle congruence theorem. This theorem says that all right angles are congruent, which should make sense. Every right angle is 90 degrees. That is what it is defined to mean to be a right angle. So if this angle is 90 degrees and this angle is 90 degrees, they are congruent, because congruent just means that they have the same measure. So the right angle congruence theorem just says all right angles are congruent. The second and third theorem kind of go together. Their only difference is one of them is about complements and one of them is about supplements. So I'm actually going to just draw a little smiley face here to remind us that these two go together. And they are also sort of going to feel like the transitive property, because what we're going to say is, if I have two angles that are supplementary to the same angle, meaning angle 1 and angle 2 add to be 180 degrees, and angle 2 and angle 3 add to be 180 degrees. Well, if that's the case, then angles 1 and 3 must also be equal, or must be congruent, in order for us to say these two things add to 180 and these two things add to 180. So let's actually just add some numbers here to give you a little bit more conceptual understanding. If I said that angle 2 was 140 degrees and angle 1 was supplementary, that would mean that angle 1 needs to be 40 degrees because they need to add to be 180. But if I said that angles 2 and 3 are also supplementary, that would mean that angle 3 needs to be 40 degrees, which means that these two angles must be the same. This angle and this angle must be congruent. So I'm going to go back over to where I have this, that if two angles are supplementary to the same angle, then they are congruent. That's the big idea. If two angles are supplementary to the same angle, then they are congruent. Similarly, if two angles are complementary to the same angle, then they are congruent. If angles 4 and 5 add to be 90 degrees and angles 5 and 6 add to be 90 degrees, then angle 4 and angle 6 must be the same, because they add to angle 5 to give us 90 degrees. So go ahead and make little notes, draw something that's going to help you remember what these 3 theorems are saying, and then we're going to move on to look at our last 2 theorems for this lesson. Okay, the linear pair postulate is really similar to what we actually defined to be true about linear pairs when we were defining linear pairs. A linear pair is angles that form a line. That's why it has the word line and pair meaning 2 angles. The linear pair postulate says, well, since these 2 angles form a line, they must also add to be 180 degrees. So if angles 1 and 2 form a straight line, meaning they are a linear pair, then they add to be 180 degrees. And then our last new theorem for this lesson is the vertical angles theorem. And what this theorem says is that if 2 angles are vertical, then they are congruent. So in this case, angles 1 and 3 are vertical, so they're congruent. Angles 2 and 4 are vertical, so they're congruent. So something I want you to notice about all of these theorems is that the vocabulary that we learned in the previous lessons is really important. In order to talk about the supplementary angles theorem, we need to know what supplementary angles are. We need to know what complementary angles are. We need to know what a linear pair and vertical angles are. So make sure that you're really reviewing those definitions so that when we're applying what we know about those terms, we are using these theorems correctly. Now that we've learned these theorems, let's look at some proofs. When we have done proofs in the past, we have focused on 2-column proofs where we have a statements column and a reasons column. And that's a very common way to prove things in geometry. When you get to higher level math, what you will see more commonly is proofs that are written out more in a paragraph form, and that's called a paragraph proof, because as we get older and we mature, it makes more sense to write things out in sentences. Another way to show a proof is to have a flow chart, and this is more of an artistic spread out, almost like you're dumping your thoughts out and then creating arrows to help you flow from one piece to the next. This is called a flow chart proof. In my class, we're only going to be assessing on 2-column proofs, but I wanted you to see this flowchart proof because it really might help your brain start processing, and it might be helpful for you to make a flowchart proof and then to wrap it up nicely into a 2-column proof. So again, you're not going to be required to make this, but our minds work differently, so having different tools that enable us to start a proof is always a helpful thing. For this flowchart proof, we're actually going to turn it sort of into a multiple choice question. So down here we have the options. These options are going to get filled into each of the blanks that we have up here for this problem. But what I'm really going to try and do is focus on thinking out loud while I am working through each of the proofs in the lesson today. So the first thing that we have here is that we are given that the measure of angle 1 and the measure of angle 3 are equal. When we do a proof, our given is always going to be the very first thing, and the thing that we're trying to prove is always going to be the very last thing, the conclusion that we're trying to make. Okay, so what we're really doing is trying to figure out the roadmap to get us from the first place to the next. If we always start with the given, then it would make sense that our first reason here is going to be given. And instead of writing given, I made this multiple choice to make our lives a little easier here. I'm going to write E. But we should always be able to fill in the first statement and the last statement. The first reason is always going to be given. Now, this flowchart proof is pointing here, but before it gets there, it has this piece here. So this is sort of like an aside, but anytime you're looking at a proof, what I want you to think is the next piece of information, if it's already given to you, does it look like the piece of information above? If so, what has changed and how do we make that change? If not, if it looks really different, then I want you to think, I need to go back to the picture. And I'm actually going to just write that below because it might be worth writing down to help your brain really understand how to process through a proof. All right, there we go. So when I look at this specific step here, the measure of angle EBA is equal to the measure of angle 2 plus the measure of angle 3. The only thing that these two steps have in common is the measure of angle 3. So this doesn't really look like this step before. So I'm going to go back to my diagram and see why is this true. So the measure of angle EBA, so EBA, this angle here, is equal to the measure of angle 2 plus the measure of angle 3. Well, that's true because the big angle is equal to the sum of the two smaller angles. And why is that true? That's true because of the angle addition postulate. Then I'm going to look at the next step. I'm going to ask myself the same question. Do these two pieces look the same? If so, what has changed? If not, let's look at the picture. So if I look at these two pieces, EBA, that matches, 2, that matches. So what is different, and I want to highlight this, what's different is that suddenly we have the measure of angle 3 here and the measure of angle 1 here. So what is changing? We are changing the measure of angle 3 to be the measure of angle 1. I'm going to look backwards. Why am I allowed to do that? Well, I'm allowed to do that because of this given piece of information that said they were equal. So I'm substituting in one thing for the next. So I'm going to put C, substitution property of equality here. Then I'm going to look again at the next piece. The measure of angle EBA, okay, that looks similar. Is angle 1 and angle 2 added together? That looks similar. So what is different? These two things are switching places. So what's happening here that's different is that angle 1 and angle 2 are swapping positions. That is the commutative property of addition. When I look at the next piece here, because this is where I'm supposed to end, I'm going to look at this piece. When I look here, all of a sudden, I do see angle 1 and angle 2 here, but all of a sudden I see this measure of angle CBD, and that seems to be coming out of nowhere. So I'm going to go back to my diagram. CBD is 1 plus 2. Oh, well, that's just angle addition, right? The big angle is angle 1 plus angle 2. So that's going to be the angle addition postulate again, which is D. And then lastly, I'm going to be looking at this step and trying to figure out how I'm getting CBD is staying in the same spot, but now I need the measure of angle EBA. So if I look at these two steps, measure of angle 1 and measure of angle 2, measure of angle 1 and measure of angle 2. Actually, let's kind of mark that up. These two things are the same, so I'm going to swap in EBA over here, which is the transitive property. If two things are congruent to the same thing or equal to the same thing, then they are equal to each other. That is the transitive property of equality. So if you really liked this format of proof, this might help you when you're setting up your own proof. If this was hard for you to follow because the flowchart isn't how your brain works, that's okay. We are always going to put things into a two-column proof in our future problems. But let's look at another proof. Okay, before we jump into this proof, which says, given angle 1 and angle 2 are right angles, prove angle 1 is congruent to angle 2. What I want you to do is I want you to look down at the statements column. There should be two things that you can fill in. I want you to go ahead and pause the video and fill in those two things, and then unpause the video and check in with me. And there we are. We should be able to fill in the two pieces of information that are given. Now this proof is partially filled in, so we're going to use what's the reason column to help us figure out how we go from this statement that we have two right angles to saying that these two angles are congruent. Over here it says the definition of a right angle. What does it mean to be a right angle? It means that the measure of the angle is equal to 90 degrees. So what I can say over here is that the measure of angle 1 and the measure of angle 2 are equal to 90 degrees. If my ultimate goal is to say that they are congruent to each other, I need to be able to write a statement that says that they're equal to each other, and then I can use the definition of congruent angles, which it indicates down here, to say that they are congruent. Well, if measure of angle 1 is 90 and measure of angle 2 is 90, then the measure of angle 1 must be equal to the measure of angle 2. And then that's the transitive property of equality. We can change that equal sign into a congruency symbol by the definition of congruent angles. So sometimes they're a little bit more straightforward, but again, we're working with what we have. We're thinking through what we see and using our roadmap to help us get there. Let's look at another proof. All right, here we go. New proof. We are given that AB is perpendicular to BC, which we can see in the picture. There's a right angle here. And that DC is perpendicular to BC. We are trying to prove that angle B and angle C must be congruent. So when I'm thinking through this proof, I'm thinking, well, this is telling me that I have two perpendicular lines, which means I have two right angles. If I have two right angles, those are both 90 degrees. So it makes sense to me that they should be equal. And that's what I'm trying to prove here. So let's look at filling in our proof. The left-hand side, the statement side, has been filled in for us, so we are just going to find the reasons. It was given to me that these two things are perpendicular. These two sets of segments are perpendicular. What it means to be perpendicular is that they intersect to form right angles. That's the definition of perpendicular segments. Definition of perpendicular segments. If both of these things are equal to 90 degrees, then they are equal to each other. That is the transitive property of equality. And really, I'm going to actually add, there should really be a measure in front of each of these. So I'm going to have you squeeze it in there as well. The measure of angle B is 90 degrees. The measure of angle C is 90 degrees. So the measure of angle B is equal to the measure of angle C. We can go from them being equal to them being congruent because that is the definition of congruent angles. Definition of congruent angles. Again, the more we work through these, the more we think out loud and process them, the easier they are going to become. Let's look at our next proof. Okay, this one looks a little longer, but all the statements are filled in. So let's look at what we are given and create our roadmap for where we're going. We're going to prove the case of the congruent supplement theorem. So we're actually going to prove the theorem that we defined at the beginning of this lesson. So given that angles 1 and 2 are supplementary and that angles 2 and 3 are supplementary, we're going to prove that angle 1 must be congruent to angle 3. So given that these two angles are both congruent to are both supplementary to angle 2, we are going to prove that they must be congruent to each other. So thinking through this, I probably am going to need to talk about how these two angles add to be 180 and these two angles add to be 180, and then maybe I can do something with that to show that they are equal and then congruent. So that's me thinking out loud. I know this first statement, or these first two statements, because that was given to me in the problem. I know that the measure of angle 1 plus the measure of angle 2 is 180, and the measure of angle 2 and the measure of angle 3 is 180, because that is what it means to be supplementary. So the definition of supplementary angles. So now I have that these two sets of angles are equal to 180 degrees. If they're both equal to 180 degrees, then I can set them equal to each other. That is the transitive property of equality. Then I'm asking myself the questions that I talked about in that flowchart proof. Looking from here to here, is something completely different? Or have I just slightly modified this? Well, what I notice is that I still have measure of angle 1 and measure of angle 3, but what is changing is that I don't have the measure of angle 2 anymore. But I notice that there's 1 on each side, so I guess I'm just subtracting that away. So that would be the subtraction property of equality. And then to go from this step to our next step, we're changing measure of angle to congruency of angles, and that is the definition of congruent angles. All right, we're going to do one more proof together, and then we're going to look at some of the angle relationships that we defined, like using the vertical angles theorem, and then we will wrap up this video. All right, we are going to try to do this proof start to finish without any statements or any reasons, really just thinking through this as we go. So let's start with our roadmap. We are given that angles 1 and 4 are congruent. We are trying to prove that angles 2 and 3 are congruent. So when I'm thinking about this, I'm thinking I need to show, I know that angles 1 and 4 are congruent. I'm going to show that 1 and 2 are congruent and that maybe 3 and 4 are congruent. So then I can say that 2 and 3 must be congruent. I know that I'm going to need to use vertical angles because that's what 1 and 2 are and that's what 3 and 4 are. And I know my ultimate goal is to stay with congruency. So I'm not going to have to switch to an equal sign at any point in time. So first thing first, I'm going to put my given information in the table. Go ahead and pause the video and put your given information in the table. I know that I'm also going to try and prove that angles 2 and 3 are congruent, so I'm going to just kind of write that down here somewhere because that's going to tell me when I need to stop, but I'm not sure how many steps it's going to take me to get there. So my first gut thought is that I can say that angles 1 and 2 are congruent because they're vertical angles, and I can also say that angles 3 and 4 are congruent because they're vertical angles. So let's go ahead and add that to our proof. There we go. So the vertical angles theorem says angle 1 and angle 2 must be congruent and angle 3 and angle 4 must be congruent. Now, if I want to relate angle 2 to angle 3, I need to first be able to relate angle 2 to angle 4 because I know that 1 and 4 are the same. So what I can actually do is, since I know that angle 1 and angle 4 are congruent, I can substitute in substitution property. I can substitute in angle 4 where there currently was an angle 1. So angle 4 is going to be congruent to angle 2. But I also know that angle 4 can be replaced with angle 3. So if angle 2 is congruent to angle 4 and angle 3 is congruent to angle 4, I can say that angle 2 is congruent to angle 3 by the transitive property of equality, of congruence. These are all congruent symbols. And that is what I was trying to prove. You could also potentially use the substitution property here to substitute in 3 for 4. Then you would have angle 3 is congruent to angle 4. Sorry, angle 3 is congruent to angle 2, which would mean you would need to use the symmetric property to switch the order of the two angles to make it match what we're trying to prove. Here, I'm just going to say if angle 2 is congruent to angle 4 and angle 3 is congruent to angle 4, angle 2 is congruent to angle 3 by the transitive property of equality. So I know this was a lot of proofs, and it's good to take breaks while you're doing them and watching them, but make sure that you're really giving yourself the benefit of the doubt. You can do this. Before we wrap up this video, we're just going to use what we learned about vertical angles here to just answer a quick question about the diagram in the next example. All right, here we have an example, and we are given that this angle is 148 degrees and that this angle is 3x plus 1. We're going to be asked to find the value of x. Well, the vertical angles theorem says that these two angles, since they are vertical, must be equal. So we can use that to solve for x. We're also being asked to find the value of QPR. QPR, well, if these are vertical angles, that means this angle must be the same as this angle, which is 148 degrees. And lastly, we're being asked to find angle TPQ. Well, it looks like these two angles, or even these two angles, are forming a linear pair, which means that the measure of angle TPQ plus 148 must be equal to 180 degrees, and then we can solve for that indicated angle. So go ahead and pause the video and finish off 6 and 8 on your own, and then unpause the video and see how you did. And there we have some examples that are using both the vertical angles theorem and the linear pair theorem. Let's go ahead and wrap up this video. All right, we did a lot in this video. In this video, we focused on proofs involving angles and some new theorems with angles. We reminded ourselves that we can do this, that we're going to start with what's given and use a roadmap to figure out how to get where we're going to end up. When we are stuck, we're going to identify if the part that we're looking at in the proof is coming from the information above, or if we need to go back to the diagram. We're going to focus on definitions and using the theorems that we've been given to be able to work through these proofs. So go ahead and write down any questions you have, and I look forward to supporting you on this. Thanks for listening.